Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to a new video. In today's video, we'll be discussing event-driven microservice architecture. So what is an event-driven interface? It is different to APIs. So how event-driven architecture works is that a message is sent after an event has happened. Say, for example, in the context of Discord, a user gets banned. So an event will be triggered where once the user has been banned, the event will then send a message to the server side informing anyone that the user has been banned, and then the person can take that event on and then deal with it how they'd like. But it's different to an API, where an API would be constantly requesting information, so there would be no delays. So the events are immutable, and in order to get services to respond to the events, this is done through an event broker. Services subscribe to an event broker, which is then referred to a hub sub. When services subscribe, they specify which event they want. So what the benefit of using an event-driven microservice architecture is that it decouples components, as the publisher does not need to know about the server subscribed, and does not need to call anything, in contrast to an API where you have to call API requests like getters and stuff. And if the server goes down, then it does not affect any other services in contrast in API, which always needs to have the server operational. However, one disadvantage is in comparison to using an API is that within API you can get real-time information. However, with the event-driven interface, that is a delay between when an event is published and when a subscriber gets it. And it's not good for e-commerce websites, such as keeping track of stock or the history, because that has to be constant and has to be updated in real time. So in Java, implementing an event-driven interface involves defining interfaces that represent events and event handlers. Components can then listen for specific events and then respond accordingly. This approach allows for greater flexibility, as the components can be added or removed without disrupting the overall system functionality. And for an diagram representation, we can see that we have our microservices which then go through our order service, and then order event is us listening for the event, the message broker, and then order event here. So example, we have an email service, so we'd listen for if we want to send an email, so an email send event would be triggered. We would then send that email through which way we see fit. So that would be our microservice 3. But we listen through events through the event-driven interface. So to get started, you want to just create a box standard project or a Gradle project. The only implementation is we'll need Lombok, but that's not necessarily required. But I'll just make life easier. So in order to get started, the first class we want to create is our event dispatcher. So what the event dispatcher is that the event dispatcher class serves as a pivotal point in an event-driven architecture. It holds the responsibility of delegating events to their suitable event handlers. So internally, it sustains a mapping of event types to the respective event handlers. This mapping ensures that the events are directed to their correct handlers efficiently, such an approach supports the decentralization and loose coupling of components, which are crucial elements of an event-driven architecture. Event handlers for specific types of events can be registered using the register event handler method, which we will create. This allows dynamic addition of event responses within the system. It is this function that ties an event type to a specific sequence of operations encapsulated in an event handler. So dispatching an event is executed via the dispatch event method, which we'll also create. This method is responsible for identifying the correct event handlers based on the event type. Upon finding the relevant handlers, it invokes the associated handling events. Note that the handling method to be invoked is assumed to be order picked. Developers may want to adjust this based on their particular system necessities. So to get started with the creating of our event handler, first we want to define a map called public. First define a map. So in here we're just going to say private final map, and in here we're going to have our class, and then our generic here is going to be question extends, and then we're just going to have object for now, because we're going to define this, and then we're going to have and in on the map we're going to have list, and in here we're going to have another object, and this is, we're going to call this event handlers equals new hash map. All right, so now we need to create the two classes which will replace these two objects. So to get started, we want to create a package called in here we want to create a package called handler, and in handler we're going to create we're going to add it's going to be an interface, and it's a handler for the interface for our email subscriber event, which we will just create before this. So you want to here can create another package called event, and then within event we're going to create it's going to be in generic, and within generic we're going to have a class called generic subscribe event. So generic subscribe event, and within generic subscribe event is just going to be an interface with just going to be a plain interface. So interface so that's going to be a plain interface, and it's a representation of a generic subscription event, which in an event-driven architecture system. An object of a type implementing this interface serves as a catalyst for a series of actions or updates that the state in an event-driven architecture system upon a subscription event. The specifics of which action should be taken or how the system state should be updated are determined by the associated generic subscribe event handler, which we will create now. So if you just go here and create another class, and we're just going to call this handler. Alright, and this is and the reason why we have this is particularly useful in scenarios where the specifics of the subscription events don't affect the event effect in the system, and instead all subscription events can be treated in the same manner. So in the generic subscribe event handler, it will just be another interface interface, and in here we're going to have it a method called void on generic event, and in here we're going to have generic subscriber event our event, and then we can just add a semicolon. And the purpose of this is a contract for the handler for generic subscription event. It's an implementer of this interface acts as the receiver for an event-based subscription mechanism. A class implementing this interface should define how it handles the occurrence of a subscription event in an event-driven architecture system. When a generic subscription event takes place, the handler then is provided by the implementing object, and this is triggered according to the specifications laid by the implementer, i.e. the developer. This is particularly useful in scenarios where the specifics of the subscription event don't affect how the system should react, and allows the system behavior to be adjusted dynamically at runtime via different implementations of this interface. So now we've done that, we can head over back to our event-driven event dispatcher, and instead of object here we will have the following. So generic subscribe event, and instead of this object we're going to have a generic subscribe event handler. Alright, now we've done that, we want to create the method which registers an event handler to an event type. The method we're going to recreate is used to attach an instance of a generic subscriber event handler to a specific type of generic subscribe event. So we're going to do public void register event handler, and in here we're going to have class, and in here we're going to have generic extend generic subscriber event, and then in here we're going to have event type, and then we're going to have generic subscribe event handler, and then we're going to say event handler. And in here we're going to have here we're going to call our hash map, and then we're going to our map, and we're going to say compute if absent. So if it hasn't been added, then we're going to add it. So we're going to say event type, and then we're going to use a lambda k. We're going to call this lambda k, and then we're going to do call a new array list, and in here we're going to just say dot array list dot add, and we're going to say event handler, and then we're going to close this off. So now we've added our event handler to release when we do the register event handler. Now we're going to create another method which dispatches the event, and this method is called because, say for example, you receive the ban event as the ban action from a Discord instance, as from the previous example. We need to tell the client that this event has been triggered, so we're going to dispatch it using this method here. So we're going to say public void dispatch event, and in here we're going to call the event we want to dispatch, and it's the event. So just fix the spelling with event here, and then in here we're going to do open this up and say one. So we're going to call vol handlers, which is just final vol handlers equals event handlers, so the mapping get or defaults event.class, so we get the class of the event we want to trigger, and we're just going to say we're going to have an empty list, collections.empty list. So we'll do that here, and then we're going to say handlers for each handlers. So we just spelled this this is just going to be handlers, and then we're going to say handlers, and then we're going to say here handlers for each, and then we're going to say handler. So we're going to call another lambda, and in here we're going to say invoke. So we're going to call a method which we're going to create now. So invoke event handler, and then we're going to say handler and our event. All right, so now we want to create this method. So the invoke handler event, what it does is it evokes an event handler to process the event. This method will call the generic event method on the handler and pass the specific event to it, and this will be specifically for that class. So I'm going to say private void, and let's say invoke. So we can just copy this here, invoke event handler, and in here we're going to have the generic subscribe the event, and then we're going, the handler, sorry, they're going to say this is the handler, and then we're going to say generic subscribe event, and in here we're going to have the event, and then we're going to do a try and catch statement just in case we receive any error. So just try in here, and we're going to say here handler dot on generic event and the event, and then we're going to do a catch here, and in here we're going to have illegal state exception, and additionally we're going to have a null point exception, null point exception, and in here we're just going to call this E, and in here we're going to say in here we're going to say throw new illegal argument exception, and in here we're just going to say error while trying to invoke the event handle method in it's good to always have a detailed error so you know where it's gone wrong. Handler dot get class handler dot get class dot get a name, and then we're going to say plus we want to just get and add some more information to process which event type, and the event type we're trying to process. So we're going to say event plus event dot get class dot get name, and we'll just throw the actual error itself for any additional information. So if it says we cannot throw this, so if you just head out back to our generic event here, we need to make just outline. We just need to do one more thing here. So we're just going to say this is a functional interface, and never mind, I meant that's wrong one, illegal argument exception here, sorry. So we also need to label this as a functional interface here, because it's a informat annotation type used to indicate that this interface is a type declaration intended to be a functional interface as defined by the Java language specification. So it's, in essence, it's just when something happens, we're going to deal with it when we listen to this event. Alright, so now we've done that, we've created our generics and we've created our event dispatcher. We're going to proceed with an example of an actual event which could occur in a real life scenario. So we're going to create a mock email event sender. So we're going to say here, so we're going to call this event, and in the event we're going to have the following. We're going to call this class, it's going to be a record, and we're just going to call this email subscribe event. If I event, and in here let me just fix this, email subscribe event, and in here we'll just one second, can't spell, sorry, email subscribe event. All right, that's fine, and this is going to be a record. So which that means you're going to need to be using Java 16 and above, and in here we're going to have, you can, if you're going to use anything below Java 16 above, you just use just a normal class, which is with an instance of the actual parameter, and then you'd have your getter, setter, etc., your toString. And in here we're just going to say string email, and then we're going to say implement generic subscriber event, and there's no, because it's empty, we don't need to implement anything. And what the purpose of this is just to represent an email subscription event in an event-driven architecture. This class is a record of an email subscription event, and this simply just captures the essential data for handling a subscription event, which in this case is the subscriber's email. And in a typical application flow, an instance of email subscriber event will be published after a user subscribes to his email notifications. This event would be then consumed by the necessary event handlers set to listen to his email subscription event, and then you'd handle information such as storing in a database, for example. Additionally, if this object is an immutable object that holds an email as an event data, meaning that this email cannot be changed later on. Alright, so once we've done that, now we want to actually create the handlers that handles what to do with this email subscriber event. So in here we're just going to say, we just copy this and create a class. In here we're going to call this class email subscriber event handler, and this class will then extend generic subscriber event handler, generic subscribe event handler, which we need to create generic subscribe event handler. One second, I need to implement it. So if you go back here, no, that's fine. Extend, because this is an interface. Sorry, not class, interface, and because we can't extend an interface obviously with a class. And in here we're just going to say this is going to call void on email subscribed event, and in here we're just going to say email subscribed events. This is called with the information we need, so it's invoked when someone subscribed to an email event, an email subscription thing. And in here we're just going to override something, override default, and in here we say void on generic event, which the event we did before. And in here we're going to do generic subscribe event, and in here we're going to say that if the event which has been triggered is an instance of email subscriber event, then we're just going to call this on email subscribe event, and then you're going to need to typecast that. So you need to typecast it, so you're just going to cast the argument. That's fine. So now we've done that, we can actually now trigger a real life situation on how this would be actually work. So one more class we need to create is called, and this is just going to be what we do with this information. So we're just in a class going to call this welcome email sender, and in here we're just going to define that we need a getter, so we'll just generate any getter method we need. And in here we're just going to say private final list in here of string, and I'm going to say subscribed emails. So this is a list of the emails which currently subscribed. Whenever we listen to any of these listeners, we just add it to this list, and then we can call this list, for example, when we're dealing with databases. And then one here we need to implement the following. So implement email subscribe event handler. So you just implement the method on here, and then we're going to say, so print out. What's it? Print. So out, and in here we're just gonna say received the email. In actual production, you would never use println because it's unsafe. So if you're listening to it, use loggers. And second of all, there would be no need to list out the emails you're listening to. You'll just be storing them directly in a database. For example, using PostSQL just as an example. All right, and now in here we're going to just say subscribed emails dot add, and then we're going to add the email. We just listen to event dot get the email. So we're going to close this off. Okay, so now we're going to mimic this in an actual situation where, for example, we get an email. So we're going to say, public static void main public static void main string args here, and in here we're going to see, so we're going to have our eval event dispatcher, and this is going to be a new instance of event dispatcher. This is going to be a new event of event dispatcher. 1 second. And in here we're going to have the following. So we're going to register the event we want to listen to. So we're going to basically register event handler. So event handler register event handler event dispatcher, and it's going to be email subscribe event.class. Then we're going to say new welcome email sender. So that's how we handle it. And in here we're going to stimulate the event being sent. So let's just say val mock email subscribe event, and in here we're just going to say new email subscribe event, and in here we're just going to say a random email, just test@gmail.com, and in here then now we're going to just dispatch the event. So event dispatcher.dispatch event, and it's going to say mock email subscribe event, and then once we call that, alright, so if we run the class now, and in here we can see that we received the email test@gmail.com. So as we can see, this is how event driven architecture works. So in summary, how in simple terms it works is that you have an event listener which you listen for an event, and then you have event handler which handles how you deal with that event, and usually you'd have a generic to make sure that whenever you handle an event, it uses that specific method. And then when dealing with the event dispatcher, you'd call the generic in your method. So only events and handlers that implement those would be able to be passed on. And then once you register event handlers you want to handle, and then once you get an event, for example, you get a request using, if you're going to use WebSockets information. For example, if a user gets banned, you'd put the user ID in here, and then you'd send that email. You'd then dispatch that event, and then you'll deal with that event in your event handler how you seem fit. So that's it for today's episode. I hope you had a great time. I hope you found this very informative, and if you have any questions, let me know down below, comment section below. Have a great time. Peace out.